This is your Pro871C locator. It consists of a headset, leads with alligator clips attached at the end, a wand or receiver. Ground stake is located here, and this is your inductive clamp if you purchase the 871C version. The first thing you're going to want to do when you set up the locator is to put batteries in it. Obviously no batteries, no power. The transmitter uses 8 D batteries that are located here in this section. You just take those screws off, the plate comes up, the batteries go in, and you're pretty much done. The 9-volt battery is located, or the compartment for the battery is located here on the back of the receiver. You just pull that little part off, put your battery in, shut the container, and you're done. The way you check to make sure the batteries have gone in correctly is basically just turn it on. If I got lights, I got power, so the battery was put in correctly. Same thing on the transmitter. If I turn it on here with a rocker switch, this light on power will come on, telling you that you put the batteries in correctly. The controls on the transmitter are fairly simple as well. As you've already seen, we have an on-off switch here, red rocker switch, simply off and on. You do have a knocking device that we call it, that when you shut the case will automatically turn the unit off. So when you're done using it, if you shut the case, you won't have any battery drain. Additionally, this control here is for low or high frequency. The 871C is a dual frequency locator. You can operate it on high or low, your choice. But you do have to operate the wand and the transmitter on the same frequency. They both have to be on low or they both have to be on high to work. It's your preference how you want to use it. The alligator leads clip in here, red to red, black to black. The inductive clamp plugs in here at the port named clamp. The wand has controls here. This is the on and off switch and also doubles as the volume control. You have a low battery light, the power on light. This is your switch to take the wand from a null or peak reception mode. Null means when you're going over the cable you get no signal, but you do get it to the right and you do get it to the left. Peak means when you're over the cable you get the highest signal. To the right it fades, to the left it fades. The frequency knob that I discussed earlier is here, low or high. Headset connection here, you'll plug in your headset here. This is the headset, comes with the unit. You have an analog meter here, that'll give you a visual indication of what your power level is, and then your external speaker, that's what you generally will listen to most of the time for signal level indication. Once you're comfortable that you've got everything with your 871, the next thing we're going to do is set it up for a locate. First thing you need to do is connect the alligator clip leads, the red and black leads. Each one has its own port, so I'm going to connect the red lead into the red port. Now these are standard multimeter connectors. So if you ever need a replacement, they're easy to find at a local Radio Shack or any supplier of multimeter cords. They're also detachable so that if one ever does go bad, it's easy to replace. You don't have to send it to us to get repaired. The black one connects in the black port, and we're going to use that for connecting to our ground stake. This is the ground stake. It comes with the unit located right here. I'm going to take the ground stake, connect to my black alligator clip, and set that in the earth ground, an actual soil ground. And we want to make that an independent ground. If you use a common ground, sometimes your slow case can get a little dicey. An independent ground is much better. Doesn't mean you can't use a common ground. We just suggest that you use an independent ground first. If that doesn't work, then try common ground. When you connect the black lead to your ground stake, there's a reason. When you set up a locator like this, what you're actually doing is transmitting a signal down the cable that you're trying to track, through the ground, into the actual dirt ground, and back to this ground stake. You're setting up a circuit. When you set up that circuit, you're creating a signal that your wand can track. If for any reason that circuit is discontinuous or open, for example, if this lead is not connected to ground or you've got a bad connection, you'll not get good current flow and you will not get a good signal and you will not be able to locate that cable. So having a good ground is important. The way you see that when you turn the unit on is this transmit light will blink brightly red if you've got a good ground. If it's weak, you do not have a good ground, and if you have no light at all, you have absolutely zero ground. This component here is called the IC2 inductive clamp. A lot of people don't know what these are for. What these clamps allow you to do is induce or place a signal on a cable without having to directly connect or disconnect the cable itself. It's a very handy piece. There's a few tips that you need to know about to use it, but the setup is a little different than the alligator clips. This cord for the clamp plugs into the clamp port here, okay? There is no grounding necessary with the alligator clips with the clamp. You just leave these clips here. They don't have anything to do with this inductive portion. With an inductive clamp, however, what you're going to do is, if my arm was this cable, I'm going to connect around the cable that I want to track. The signal now is being induced through this clamp into the cable and allows you to track it. But there's a couple things you have to keep in mind. First of all, both ends of that cable have to be grounded. We talked about briefly that you need to create a current. This also creates a current, but again, you're not using an alligator clip for a ground. You're using the ground of the cable on both ends as you're grounding. And it's sending a signal down that cable, through the ground, back through the ground again, and that's how you create your circuit. Number two, if that's going to work, this clamp has to be placed between those two grounds. If you place it on the outside of one of those grounds, you do not have a circuit available to create that current. Additionally, as we send that signal down the cable, when it gets to that point where it's grounded, that's where the signal stops. It doesn't go any farther than that, okay? So the clamp is a very handy piece to use, very easy to use. You just have a few parameters that you have to keep in mind. Now that we've set the black lead up with the ground stake, we're going to set the red lead up on the cable that we want to track. This is going to be a direct connect. When we use direct connect, we're using the alligator clips, not the clamp. We've disconnected this coaxial cable that runs into this home, and we're going to take the red clip and connect it to the sheath of the cable, okay? We connect to the sheath, not the center conductor. The center conductor is insulated by the sheath. If I connect to the center conductor, the best signal, or the most powerful signal, is not allowed to get out of the cable. It's being insulated inside that cable, so that's why we use the sheath. Connect the red alligator clip here, and we're ready to go locate. Now we're ready to locate. We've got the black lead connected to our ground stake, and we've got the red lead connected to our cable that we want to find. We've turned the transmitter on. One very important tip at this point, though, is please check the transmit LED, the red LED on the transmitter, and make sure that that LED is blinking brightly and continuously. That signal tells you that you have a good ground and you're going to have a good locate. If the light is weak or non-existent, it's not blinking at all, then you do not have a good ground, or you have a disconnection in your system. So recheck the alligator clips, make sure they're good, well connected. Recheck the alligator clips connected in the transmitter, make sure they're plugged in all the way. As long as you've got that red LED blinking brightly, you're good to go. When you do your locates, of course, common sense comes into play. In this situation, we can see that our transmitter is coming out of the house, or the cable's coming out of the house here, and there's a connection box in the road, so there's a pretty good chance that that cable is going to run through this section somewhere in here. Not likely it's going to go out back, but I'm going to scan this area real quickly. In the null mode, I have the transmitter and the receiver both on high frequency, and I'm going to listen for that null to find where that cable path is. So I put it on high, I adjust the frequency to a low level because I want to give it the ability to change volume levels so I can hear it. And I'm going to scan real quickly here where I think the path of the cable probably is, looking for the null. Whoops. Very likely right there. I'm going to scan a little bit more, and it's starting to fade out. That's a pretty good indication that I found the cable back here. Okay. Now I don't need it banging that loud, so I can turn it down a bit. If I want to use my headset, the only difference would be that sound's coming through my earpieces versus here on the receiver. And now I'm going to track it. And as you hear that null, when I point directly at the cable, that's where that cable is located. A little bit to the right, a little bit to the left. That's why I personally like the null mode. Now you can switch it if you want to the peak mode and hear the difference. As I go over the cable, it gets louder. As I go to the left, it fades out. As I go to the right, it fades out, okay? I prefer null, so I'm going to go back to null. And now I'm going to track it across the yard. Swing it far enough so you get some good indication of signal on both sides. Nice and steady. As long as you got that null, you're going to follow the signal. And as I thought, I'm heading right towards that connection box. Turn down a little bit. Going off this way a little bit. And I'm going right to the connection box. Now if I had marker paint, I would paint that track and I'd have it right down to this box. There we go. We used the locator to find the cable TV line that ran from the house out to the cable box. At least we assume that's the cable line, but in doing a survey of the rest of the yard, I also found a signal here in this section, another cable. To show you that, I'm getting a null right here. That means there's another cable run through here. This is a common symptom known as bleed over. I've got two cables giving me a signal, and I don't know which one I'm looking for. Now, in this situation, we were able to track it to the cable TV box, so we're pretty sure that's the cable TV. However, if you don't have access to those boxes, or you're just not sure which one of these is the right one that you're tracking, here's a simple technique to get rid of that confusion. Over this cable, find the path of the cable, find that null. Okay, there we are. I want you to put the tip of the locator on the ground and turn the locator volume down to a spot where you can see it on the analog meter. That is easily readable. This one says just about a 6. I'm going to take this now without touching the volume control. I'm going to take it over to the original locate that we had, and I'm going to check this locate and see what I get on my analog meter. If it's larger than a 6, then I know this is the right cable. If it's less than a 6, I know that's the right cable. Now I can already tell you by this, just the audio that I'm hearing, it's a lot louder over here. There's my null, and I can't get it anywhere near 6, it's over 10, okay? So this is obviously the cable that I'm directly connected to. This is a great example of bleed over. This is the cable that I'm directly connected to, but that cable's getting signal too. How does bleed over work? These cables, when you transmit a signal down them, set up an electromagnetic field around that cable. This receiver senses that field and gives you an audible signal telling you, hey, you're near that signal. When another cable or another conductor runs through that field, it also picks up some of that signal, and that's called bleed over. And that cable over there is picking up some of that signal. And by using the technique I just showed you, you can distinguish which of the two is one you're connected to and which one is not. A couple of factors on bleed over: the longer a cable runs with another cable, the more bleed over it's going to have. The closer the proximity, the more bleed over it's going to have. Okay? Good rules of thumb to remember, but that's a simple technique for discerning which of the two cables is the one you're actually connected to and which one is the one that's been bled over to. An alternative way to connect to a cable without disconnecting it is to use the inductive clamp. As we showed you earlier, you plug this clamp into the clamp port on the transmitter, turn it on, you'll get that bright red blinking LED, and then you take the clamp and connect it around the cable like this, okay? At this point, the cable or the clamp is inducing a signal onto the cable. You can now track it. As we mentioned, there's a couple of tips though. Both sides of the cable need to be grounded. You can't have one end sticking in the air. And you have to connect with the clamp between the grounds. The amount of distance you're going to get with a clamp is less because you're reducing a signal as opposed to directly connecting. And you do have to use it in high mode. You have to use it in the high frequency mode for the signal to be able to induce into the cable. But other than that, you're ready to go. Finding depth with the Pro871C is easy. We use the triangulation method. The first thing you want to do is find the path of the cable. We prefer to do it with the null method. That's the most accurate way to find the exact location of the cable. Once you've found the exact location of the cable, you mark it either using marking paint or some other method that you prefer. This graphic will illustrate how we use the triangulation method to find depth of a cable. The horizontal distance or horizontal leg on a right angle triangle or a 90-degree triangle is equal to the vertical leg. So if we can figure out the distance of the horizontal leg, it will tell us how deep this cable is. The way we do that is quite simple. In practice, here's what we mean. When the wand is on a 45-degree angle and pointed directly at the underground cable, you'll get the null signal again. It is critically important that you have the wand at a 45-degree angle. The distance that the tip of the wand is from the spot where you marked the cable path is the approximate depth of the cable.